Here are ways to have variations on the theme of a tangent function, and cotangents work the same way. We would just put cotangent in there instead of tangent. These are going to work the same way that transformations of graphs have always worked. There's nothing new under the sun. We're just going to look at what it looks like for these particular kinds of graphs. So I have a tangent set up here. If I change a, the number out in front, to a different positive number, I get a vertical stretch. When we talked about sinusoids, we called this amplitude because for sinusoids, there was a definite top and a definite bottom. That's not true for tangent graphs. They go on infinitely. So we're just going to call this a vertical stretch by a factor of a. Think of grabbing hold of the top and the bottom and pulling them apart, one end up, one end down. The bigger a is, the bigger the amount of the stretch. If I go back the other direction and let a go into negative values, then I do get a reflection, vertical reflection across the x-axis, which also is kind of standard for a graph. If I put a negative sign out in front, I get a reflection, and I'm going to put this back to 1. So vertical stretch is a, the number out in front. If I add something on the end, this b over here, that also is going to do what it's always done. It's going to move the entire graph up or down by the amount b. So if I put, it's kind of fun to watch. If I put b equals 4, now instead of a point at 0, 0, I have a point at 0, 4, and everything has moved up by 4. If I make b negative 3, now my point that used to be at 0, 0 is at 0, negative 3, and the entire graph has moved down by 3. And we'll see if I can put it back in the middle. Oh, had it for a second. There we go. Like sines and cosines, this is, I know it looks like a W, and technically this is a W because Desmos doesn't know what omega is, but it's an omega, a Greek letter omega, and this is going to change the period. The period of the tangent function and also the cotangent function is pi. Between the asymptotes at minus pi over 2 and plus pi over 2 is a distance of pi. So to find the period of a variant of a tangent or cotangent function, I'm going to take the original period of pi and divide by omega, whatever is the coefficient of x. If my coefficient of x is large, and it'd be really good if I was moving the right one, which I'm not. If the coefficient of x is bigger than large, meaning bigger than 1, the period gets smaller. If the coefficient of x is between 0 and 1, it's going to stretch up and the period gets longer. So theme and variations for tangent and cotangent. I will just mention with sinusoids, we also talked about a phase shift. That's definitely something that we can do. With tangents and cotangents, it would work the same way. The phase shift is phi divided by omega. We're not going to do that with these, but you definitely could. And I'll go ahead and stick a cotangent in here just for a minute so we can see, yes, it really does work the same way. Vertical stretch, the period change, and moving up and down. And of course you can do all, some, or none of those.